In this video, I'll run through some examples of Gauss Jordan elimination with three variables. Let's suppose we have this system of three linear equations: 2x plus 2y plus 4z equals minus 2, x plus 4y minus 4z equals minus 1, and 4x plus 4y plus z equals 3. So to solve that system using Gauss Jordan elimination, we set this up like this, with the numbers multiplying the x, y, and z's on the left hand side of the line, and then the numbers on the right hand side of the equation on the right hand side of the line. And we'll use row operations to change the numbers on the left hand side into reduced row echelon form, so ones on the diagonal and zeros everywhere else, and then on the right hand side we'll be left with the solution. So first thing, we need a 1 up here, and one way to do that is to divide through by 2, but another way, which is a little more efficient, is to just interchange these two rows, and then I'll get a 1 up here straight away. So let's do that. So second row will become the first row, and the first row will become the second row. Okay, next we want to get zeros here and here. So to get a 0 in the second row, we can subtract 2 times the first row, and to get a 0 in the third row, we can subtract 4 times the first row. So let's do that. We're not doing anything with the first row now, so we'll just write it down again. And then the second row, we're subtracting 2 times the first row, so we'll get 0, and then we'll get 2 minus 2 times 4, so 2 minus 8, which is minus 6. And then we've got 4 minus 2 times minus 4, so 4 plus 8, which is 12. And then we've got minus 2 minus 2 times minus 1, so minus 2 plus 2, we get 0 here. And then third row, we're subtracting 4 times the first row, so we'll have a 0 here, and then we've got 4 minus 4 times 4, so 4 minus 16, we'll have minus 12 here. And then we've got 1 minus 4 times minus 4, so 1 plus 16, so 17 here. And then we've got 3 minus 4 times minus 1, so 3 plus 4, we'll have 7 here. Okay, next step, we'll get a 1 in the middle here, so divide through this second row by minus 6. So just write down the first row again, because we're not doing anything with that at this stage. And then second row will become 0, 1, minus 2, 0, and then the third row, we're not doing anything with the third row in this step, so just write it down again. Okay, next step, we want a 0 here, so if we subtract 4 times the second row, we can get a 0 here, and we also want a 0 here in the third row, so if we add 12 times the second row, we'll be able to get a 0 there. So let's see, so first row we're subtracting 4 times the second row, so we'll get 1 and then 0, and then we've got minus 4 minus 4 times minus 2, so we've got minus 4 plus 8, so we'll have plus 4. And then we've got minus 1 minus 4 times 0, so we'll get minus 1 here. Second row we're not doing anything with at this stage, so we'll just write it down again. And then the third row we'll have 0, 0. We're adding 12 times the second row, so we've got 17 plus 12 times minus 2, so 17 minus 24, which is minus 7, and then we'll have 7 plus 12 times 0, so we'll get 7 here as well. Okay, next step, change this to a 1, so divide through this entire row by minus 7. So the first two rows are unchanged in this step, so we'll just write them down again. and then the third row we're going to divide by minus 7, so we'll get 0, 0, 1 and then a minus 1. Okay, we're nearly there. We need zeros here and here to get a 0 here. If we subtract 4 times the third row, we'll get a 0 up here, and we need a 0 here, so if we add 2 times the third row, we'll get a 0 there. So let's do that. So we're taking the first row and subtracting 4 times the third row. So we'll have 1, 0, 0, and then on the right hand side of the line we've got minus 1 minus 4 times minus 1, so minus 1 plus 4, so plus 3, and then middle row we're not doing anything with, oh no, we are doing something with the middle row. We're adding 2 times the third row, so we'll get a 0 here, and then let's see, we've got 0 and we're adding 2 times minus 1, so we'll have minus 2 here, and then 0, 0, 1 and minus 1. Okay, so I think we have a solution. So let's check that our solution is correct. Our solution is x equals 3, y equals minus 2, z equals minus 1. So let's plug those numbers into the first equation. So we'll have 2 times 3 plus 2 times minus 2 plus 4 times minus 1. So that's equal to 6 minus 4 minus 4. So that's 6 minus 8, so minus 2. And that's what it's supposed to be. Okay, let's check the second equation. So this time we've got 3 plus 4 times minus 2 minus 4 times minus 1. So that's 3 minus 8 plus 4. So that's, let's see, 3 minus 4. So that's minus 1, and that's correct as well. And lastly, 4 times 3 plus 4 times minus 2 plus minus 1. So that's 12 minus 8 minus 1. So that's 12 minus 9. So that's 3. And that's correct as well. Okay, so it looks like we got the right solution. So that's one possibility, is a unique solution. 2 other possibilities, and one is that there's no solution. So if we have this system here, so I've performed Gauss Jordan elimination on this. So again, I've interchanged the first 2 rows for this first step. For the second step, I'm trying to get zeros here and here, and so I'm subtracting 2 times the first row to get a 0 here, and then I'm subtracting 5 times the first row to get a 0 here. And if I do that, I end up with this system here. And then next I want to get a 1 here, and so I divide this whole row by minus 6. So that's what this step is. And then I want to get zeros here and here. So to get a 0 here, I subtract 4 times the second row, and to get a 0 here, I add 12 times the second row. And I end up with this system here. And when I do that, I end up with another 0 here. So I've got zeros all the way across, but I have a non-zero on the right hand side of the line. So that means there's no solution. Last scenario is if there's an infinite number of solutions. So I've got this system here to illustrate that scenario. So everything's the same essentially except for this number here. If you compare this system over here with this system here, the only thing that's different is this number. It was 3 over here, but it's minus 5 over here. So all these steps are the same, except till we get to this step here. And with this step, we're trying to get a 0 in the third position. So we had a 5 in the previous step, so if I subtract 5 times the first row, then I'll get a 0 here, and if I do that, I end up with a 0 here, whereas before I had an 8. And that has implications further down, because if I keep going, I end up in this step here with zeros all the way across, just like I did over here, except now I don't have an 8 here, I end up with a 0. And so that means I've got an equivalent system where I started with 3 equations in 3 unknowns, x, y, and z. Now I've ended up with 2 equations, but I've still got 3 unknowns, as that means there's an infinite number of solutions. And we can write those solutions in parametric form if I set z equal to t, and then y, we can see that y minus 2z equals 0, so that means y equals 2z, and z is t, so y is equal to 2t, and then x, here I've got x plus 4z equals minus 1, so x is going to be minus 1 minus 4z, so x equals minus 1 minus 4t. So that's a way to write the solution set here in parametric form, and you can see that that represents an infinite number of solutions because t can be anything. For example, if t was 0, z would be 0, y would be 0, and x would be minus 1. If t was 1, z would be 1, y would be 2, and x would be minus 5. So an infinite number of solutions in this case.